Assalamualaikum, hello. My name is Mohamad Haikal bin Huzainizam. My metric number is DD180017 and I'm from group 3C, section 3 from class Dr. Muhammad Farid bin Sies. So today, due to COVID-19, and all classes need to run online, so we will present our open-ended experiment through video presentation. So, in this video, we will share about our experiment of reversible steady flow for multi-stage compression with intercooler, and it consists of 7 subtopics in this presentation, that is introduction, experimental theory, experimental procedure, result, observation, discussion, and lastly conclusion. So before we start, I will introduce to you my group members, and every member will present their subtopic according to what we have divided. So let's proceed.
Okay, my name is Muhammad Iqmal bin Sarif. My metric card number is BD180047.
My name is Noor Ameera Salfryeinna. My metric number is CT170095.
Hi, my name is Izza Farisya bin Hamdan, AD170009.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilman bin Hussein. My metric number is DD180033.
For this subtopic introduction, we explain what the air compressor is and how it works. Also, comparing the efficiency of air compressor between single stage and multi-stage. By the end of the introduction, we explain the main objective we conduct the experiment and also our hypothesis for the experiment. Compressors are mechanical devices that can compress substances in gaseous state, means that it is a machine that increases the pressure and temperature of air. During the process, the intake pressure of the air is usually raised to a higher exhaust pressure. Reciprocating air compressor may be single stage or multi-stage. The main difference is the number of times the air gets compressed, which is in single stage once, and in two stage the air compressed twice, whereby increasing the number of cylinder stage and pressure, the machine works more efficiently. In this experiment, we investigate the effect of intake pressure and the efficiency of the air compressor, where the higher the pressure, then the more efficient the compressor is. Data were obtained and relevant thermodynamics equations were used for the calculation.
Okay, now we will proceed to the experimental theory of this experiment, where we will discuss about what is multi-stage compressor, why it is called a multi-stage compressor. We will explain step by step of the working of a multi-stage compressor and some of the theory, some of the equation or formula used to calculate the experimental data for this experiment. So let's proceed. Okay, what is a compressor? Compressor as well as pump and fans are devices used to increase the pressure of a specific fluid. Work is applied to this device from an external source through a rotating shaft. Therefore, compressor involves work input. A compressor is capable of compressing the gas to a very high pressure. So, the main objective of a compressor is to increase the pressure of a fluid into a higher pressure without increasing the temperature. Next, why does it call a multi-stage compressor? In multi-stage compressor, it consists of 2 or more cylinders used for air to be compressed. Multi-stage compression is done to achieve high pressure ratio. When the compression ratio exceeds 5 bar in the compressor, generally the use of multi-stage compressor is adopted. Figures show the close-up of an air compressor 2 stages, which consists of first stage cylinder, second stage cylinder, and lastly the intercooler. The basic responding air compressor has a cylinder which responds inside the cylinder wall and cylinder head. The piston is joined to the crankshaft with the assistance of an interfacing bar or connecting rod, and the rotation of the crankshaft makes the piston go all over inside the chamber in up and down movement. The crankshaft is mounted on the crankcase. The cylinder head contains both pockets where the suction and delivery valve are fixed. For step 1, at the point when the blower stops and sits for quite a while, it is constantly accepted that there is some remaining pack and left air in the cylinder space. This left air grows or expands when the cylinder descends. The pressure drop in the cylinder space at a specific point of the cylinder goes down, where the pressure inside the cylinder gets lesser than the atmospheric pressure. This distinction in pressure makes the suction valve open. Next step, step 2. This opening of inlet valve permits natural air to be drawn inside the cylinder space as the piston, despite everything, keeps on moving the downward direction. The inlet valve will stay open till there is pressure difference between the environment and within the cylinder space. As the pressure difference begins to decrease, the inlet valve begins gradually shutting. The inlet valve closes totally when there is no pressure difference, and afterward, the piston arrives at bottom dead center, or BDC, and it begins to go an upward way. At this position, both the inlet and delivery valve will stay closed. For third step, step 3, the delivery valve begins to open when there is a pressure difference between the chamber or cylinder space and air receiver. As the piston moves upward and the pressure grows, and sooner or later the pressure develops greater pressure, making the delivery valve open. In this manner, the compacted air is conveyed into the air receiver. And lastly, step number 4. As the piston arrives at the top of the cylinder, the constraint pressure begins to fall, and the delivery valve begins to close. The leftover packed air staying in the space again begins to grow as the piston descends, proceeding with the following cycle.
For the procedure part, we explain step by step how to conduct the experiment from step 1 until step 8. For procedure, step 1, check the flow rate of cooling water, adjust using the valves, then connect the water inlet and outlet properly. Step 2, plug in the flexible cable into the diaphragm D1 for compressing air at P4 equal to 2.5 bar absolute. Step 3, start the air compressor by turning on the main switch on the control panel. Step 4, record the data for the suction conditions, then wait for 10 to 15 minutes to reach steady state. Step 5, record the value of temperature and pressure in the column first stage compressor and wait for 5 minutes. Step 6, fill up the values in the column second state compression and wait for another 5 minutes for final compression. Step 7, record the rest of the data in the tables. Step 8, repeat step 1 until 7 for P4 equal to 4 bar and P4 equal to 7 bar absolute by replacing cable flexibly into diaphragm D2 and D3.
In this subtopic, I will show you the result from our experiment of multistage compressor. For the experiment, we actually need to set the compressor into 3 different pressures stated as P4, that is 2.5, 4 and 7 by the unit of bar. So, as you can see, the ambient temperature and pressure is recorded, that is labeled with TO and PO, and followed by the first state of compression labeled as T1 and P1, and beta 1 is the efficiency of the compressor. Next, we go to the second state of compression, that is labeled of T2 and P2, and also we can see the final compression is labeled as T3 and P3. Also, we have T4, which located as at the final compression. Next, throughout the experiment, the other thing that need to be recorded into table is the tank temperature, denoted as T5, for every pressure, the water circuits W1 and W2, which is initially set at 100, the airflow rate, the input power, the air tank, exchange water inlet, exchange 1 water outlet, exchange 2 water outlet, that's denoted as T6, T7, T8 and T9 respectively. All data need to be recorded step by step following the difference in pressure, that is 2.5, 2, 4 and 7.
My part is observation. In the observation, I will say about the how to conduct the flow, and the hypothesis.
First of all, make sure that the flow rate of cooling rate is sufficient, approximately 100 liters per hour. Before a compressor turn on, all valves are checked to be closed. The compressing air that is known as P4 of or fixed value. P4 is equal to 1.5 bar. The flexible is connecting to the diagram P4 equal to 4 bar and P4 equal to 7 bar. After P4 is kept at constant value, such as 1.5 absolute, the ambient air temperature and pressure recorded through the table 1, T0 and P0 value for ambient air. The system is led to get the steady state condition by waiting 10 minutes. Value of temperature of each pressure is increased. Pressure of ambient air is decreased. Result obtained from the first state of compression after waiting 10 minutes. It increased with respect to temperature 1 and pressure 1 as they influenced by the increased value. The value is shown in the table 2 for the first state of compression value. Temperature difference for the 3 pressure and value for pressure difference between P1 and P0 also increase. This is shown in the table 2 also. The first stage can be said to be linear. Second stage compression has temperature and pressure reading due to P4 value that waiting another 10 minutes of temperature 2, temperature 3 and pressure 2. All value is increased. All the value are on the table 3. For temperature 4, temperature reading is decreased 113.7 degrees Celsius, 35.5 degrees Celsius to 22.4 degrees Celsius, and increasing the pressure value were 1.5 bar, 4.0 bar, 5.8 bar. It's known as final compression. The value of air flow rate decreased because when the high value of P4 in the compressor, the minimum air flow rate. So the value is 11 meter cube per hour, 6 meter from 11 to 6 meter cube per hour to lastly 2 meter cube per hour. It's required high power input due to increasing the pressure value. The power value for the 2.5 bar pressure is 3.5 kilowatt. 4 bar pressure is 4.4 kilowatt and the last is 4.2 kilowatt for 7 bar. The hypothesis has been made is about of intake pressure and efficiency of the air compressor where the higher the pressure, the more efficient the compressor is. That's all for me. Thank you.
For calculations, we managed to calculate polytrophic coefficient N, polytrophic work W, and polytrophic efficiency of compressor. For polytrophic coefficient, the value obtained for 2.5 bar, 4 bar and 7 bar are 0.557, 0.7764 and 0.8049 respectively. Next, for polytrophic work, the total work obtained for 2.5 bar are 50.0143 kJ per kg, for 4 bar 229.404 kJ per kg, and lastly for 7 bar 310.574 kJ per kg. For polytrophic efficiency of compressor, the value obtained for 2.5 bar, 4 bar and 7 bar are 0.237%, 0.518% and 0.220% respectively. Next, we proceed to discussions. Based on the experiment, use of air compressor can be considered as open system. Air entered the compressor by inlet valve. Next, the pressure is increased by compressing the liquid, and finally, air enters storage vessels by outlet valve. Based on the results obtained by this experiment, the hypothesis is rejected. This is because, based on the calculations, the efficiency does not increase with the pressure as stated in the hypothesis. There are some errors throughout this experiment, such as parallax error. Eyes of observer may not be perpendicular to the reading scale of the machine, hence, this gives us inaccurate results.
Okay, now I will explain to you about the conclusion for this experiment. Okay, from the data, we can conclude that compared to a single stage compressor provide a higher efficiency of air compression work. Two-stage air compressor is implemented when greater efficiency and lower power input allow high output pressure. The higher the output pressure with low input power, then the more the paces. The overall output of the multi-stage compressor depends not only on the compressor itself, but also on the output of the motor and volumetric performance. We find that the high airflow compressor generate only low power input. Function flow rate can be called free air delivery, which is defined as air under actual atmospheric condition is critical in calculating the indicated power input. We show that the compressor efficiency depends on the compressor function flow rate and motor speed. Intercooler and aftercooler play on important roles, and the multi-stage air compressor to increase device efficiency by cooling the heat generated during compression and to remove the moisture formed during compression respectively. The mistake may have happened during the experiment since the pressure and temperature level of the rig must be constant and time consuming. This may have resulted in error during the calculation. In order to overcome this error and to get the accurate value and time, firstly, the person doing the experiment need to wait until machine reach stable condition, and before the experiment is conducted, the machine use must be ensured to be functioning well. Thank you.